fraction, right. Thank you. Okay.
Oh, yeah.
All right, so this is going to be sort of a repeat.
Oh,
But it will be a little bit new as well, because I've not talked about this as an actual topic as much as I've used this method with you guys for solving number word problems already. So you've already experienced the idea of substituting things in. But it's important to understand that, last night's homework we were graphing. And many of you, for one of those problems, you said as your answer, you said not easy to solve by graphing, right? Because it wasn't clear. It was like, your x and y intercepts were fractions, and you weren't sure exactly where they were in the box, and you didn't trust exactly, what, but you didn't trust exactly where things were going to be, so you couldn't draw your line straight. Does that make sense? So graphing can be fun. It's fun to solve them by graphing, but it's not really practical because a lot of times they're not going to be easy solutions, right? Or at least sometimes. In real life, they're not going to be easy solutions. You're not going to get lots of whole numbers in real life. If you were doing a real life situation, you're going to have fractions as your answers. And that's going to make it really hard to find when you're graphing, right? But most of what I'm going to give you are going to be where you solve it and you get whole numbers with your answers, okay? So systems of equations means what?
Wow.
I'm impressed. Systems of equations versus an equation.
It's more
There's
than
an
one.
equation.
It's more than one.
More than one equation, right? It's more than one
Smart.
equation. Exactly. So, but if you have more than one equation and you have two variables, you have to basically if you have two variables, you have to have two equations, right? In order to solve them. Because if I said, let me see, what's the first one? If I said, y is equal to, here's number one. If I said y is equal to, what did I just say? X plus 4. All right, what does x equal?
47.
What?
It equals a line.
What?
Yeah.
What is x equal? What does y equal?
Y equals x plus 4.
But yeah, I need a number. What does it definitely?
4, 8.
200.
It can be anything.
Oh, it could be anything, right?
It's got
That's why when we graph a line like this, there's an infinite number of possibilities. If x were 0, y would be 4. If x were 1, y would be 5. If x were 2, x were 6, right? So, right? It keeps going, right? And so that's why we have to graph it as a line with arrows on each end because it goes on forever, right? With systems of equations, we're being asked to find one point. We have one equation, a line with one equation, then we suddenly have a line with another equation, right? And they intersect. And we're being asked to find that intersection point. Does that make sense? And so what we're going to, so guys, can you guys stop the drawing right now? I'm trying to teach a lecture, okay? And the talking. Besides, there's a lot of talking. Okay, James, please?
Yeah.
Are you taking notes?
Yes.
Okay. All right. So I have two unknowns here, don't I? And there's no way I'm going to know what y and x are right now. There is just no way. It's impossible. I know what they could be, but I do not know what they are. Right? This would not be a very safe way to send somebody to the moon, right? What's the gravity? Well, if x was 0, y would be, that's not going to help, right? Right? We need to know concrete answers. But there are two unknowns. If I gave you another equation, then we would be able to solve this very easily. Here's another equation. Is that an equation?
Yeah.
It's an equation. It has an equal sign. It says y equals 10.
Well, 10.
All right, so what I'm going to do, I'm going to do an algebraic method. I am going to use substitution. I'm going to take this 10 here, and I'm going to replace, since that is the same thing as a y, right? Base, are you watching, buddy? since 10 is the same thing as y, I'm going to replace this y with 10. Because I know that the y's at this one point are identical.
So x equals 6.
Does that make sense? So suddenly, I'm going to replace this y with 10. So suddenly, if I do that, I have 10 equals x plus 4. What do I do now?
X equals 6.
I subtract 4, right? Subtract 4, and I get 6 equals x. Right, good one here. Okay, x equals 6, right?
Yay.
All right, what's y? Y is 10. You always want to give me both coordinates, right? So that was easy, right? Fist of 5. Did that make sense?
Ooh, let's get the homework.
Fist of 5?
Let's
Okay.
get the homework.
All right, that's number 1.
Espérate un momento.
Number 2. Now we're going to make it a little harder. Y is equal to 2x plus 5. And then, let me think here. I'll say this. Y is equal to negative 3x plus 10. I have two equations.
Substitute.
So what I'm doing, these are my steps for systems of equations. Right? Number 1, find equation that says y equals or x equals. Right? I want an equation that says y equals this or x equals this. Do I have an equation in that situation?
Yeah.
Yeah, which one?
The top and the bottom.
Both of them. Oh shoot, then what do I do?
That one. You pick one and
I pick one. I pick one, it doesn't matter, I'll pick this one. I will circle what y equals. Okay, so 2. Circle what y or x equals. Right? Right? And then I draw an arrow. What does that equal? That equals y. I'm going to draw an arrow to the other y. Right? Does it make sense?
Yep.
And I'm going to substitute this one in for this one. Right? Because I know the y's at that point are identical. Does it make sense? You see what I mean? Okay? So now suddenly I have an equation that's this equals this. Right? So we have 2x plus 5 is equal to negative 3x plus 10. Now what do I do? Luke, do you have a question?
Yeah, couldn't you also do negative 3x plus 10 equals 2x plus 5?
I could.
maybe.
Now I could have circled either one. When I asked that question, Gardner said circle one of them. Because they both say y equals, right? So I could have circled this one instead. And then if I did, then I'd draw an arrow to this y. And I would start with negative 3x. The reason I chose this one is I wanted to have my x's on the left side. My positive x's, right? If I had done the negative 3x over here, then I'd have to add 3x and I'd have positive x's on the right side. I'd rather have my x's on the left.
Is this another way to solve stuff?
So, yes, yeah.
Oh, this seems a little bit.
This is actually a very, very powerful method, right? So I'm adding 3x to both sides, and I'm going to, at the same time, since I'm moving the x's to the left, I'm going to move all the numbers to the right. Does that make sense, Basie? I'm moving the 3, well, that's okay. I'll just do one thing at a time. So suddenly I have 5x plus 5 is equal to 10. Is that clear?
Yeah.
Basie, is that clear? All right. And then I'm going to subtract 5. Subtract 5. I have 5x is equal to 5. Divide by 5. Divide by 5. X is equal to 1, right? Am I right? Am I done?
No.
You're never done until you give me what?
X and Y.
X and Y. What? So I need, if I know X is that, what is Y?
Substitute that.
I'm going to substitute that. So I'll just, which one do I have to substitute it into?
Y is 7.
Which one do I have to substitute it into?
Anyone.
Anyone. It doesn't matter. It doesn't matter, right? So y is equal to 2x plus 5, so 2 times 1.
Kind of like word problems, but a little bit more.
So 2 plus 5, which is 7, right? So y is 7. Well, exactly. This is exactly like the number word problems that I taught you, right? It's the same process. That's why I was telling you it's repetition. But I have to go over it clearly, and so you understand this is what systems of equations is by substitution. Okay? So Mushi and everybody over there, you guys are talking, right? Can you stop, please? Okay. Fist of 5. Are you guys still with me? Is
Yeah.
it making sense?
Yes.
Fist of 5. Okay. So number 2, number 3. Let's do a third one. What if I gave you this? What if I gave you, let's see here, let's try this. No, I don't. Okay, that's fine. Okay, what if I gave you this? X is equal to y plus 3 and x plus 2y is equal to negative 6. All right, what do I do? Shh, guys, James,
Yep.
what do I do? Gardner,
You have to make it y equals
why?
two.
Look at my step number 1. Find an equation that says either y equals or x
So-
equals.
You're gonna use the first equation.
Yeah, x is the same as that. So I'm going to circle that.
Yeah.
Does that make sense? I'm going to circle that. I'm going to draw an arrow to what?
Y. Y.
Well, wait. This is equal to what?
Wait, and.
It's equal to x. So I'm going to draw it to what it equals, x. Does that make sense? You guys see the difference? Now we're dealing with x, right, and not y. All right, so now I'm going to plug this in for x. So that's y plus 3 plus 2y is equal to negative 6. Okay? And now notice all I have left, Jaden, all I have left here is one equation with one type of variable, y. So I can solve for y, right? If I have one variable, one equation, I can solve for it. If I have two variables, I need two equations. I started with 2, I condensed it into 1. So now y plus 2y is 3y. 3y plus 3 is equal to negative 6. Subtract 3, subtract 3. 3y is equal to negative 9. Divide by 3, divide by 3. Y is equal to negative 3.
And x is equal to 0.
And x, well, no, what is it? Oh yeah, you're right. X is equal to negative 3 plus 3 is 0. There you go. And we are done.
It was pretty
Now,
simple.
if you wanted to, you could also give the answer in a different method. What's another way, Jan, that you could actually give an answer? What's another way that you could answer this?
You could try
I said y is negative 3, x is 0. How else could I give an answer? Resmer.
x is a 3.
No, I can't swap the numbers, but I could write it in a coordinate point form. Because we're talking about where two lines intersect.
Yeah, you could just make it, you can make it
So,
0, negative 3.
I
and then
could
you
write
can
it
graph
0,
that
comma,
point
negative
and
3.
the line goes.
That is also an acceptable answer. Does that make sense?
Yeah.
See that? Okay, what would this one be? Luke? 1 comma 7, exactly. All right, fist of 5. You're starting to make sense? You think, you feel like you're comfortable, I can just give you the homework?
This is pretty easy.
Awesome, okay.
Gary.